Good day, everyone. I am Kirk Miguel Beltran, and today I want to talk about one of the most common misconceptions in basic electromagnetism, especially among students and people who are just beginning to study physics. The misconception is this: electric potential and electric potential energy are the same because both describe stored electrical energy. And at first glance, this actually sounds reasonable. After all, both concepts involve energy. Both are measured when discussing electric fields, and many textbooks introduce them almost side by side. But as we'll see, they are actually two different physical quantities. And by the end of this short discussion, I hope that you'll not only know the difference, but you'd also understand why so many people naturally confuse them. So let's first understand why people think this. Now, imagine you're hearing these terms for the first time. You hear electric potential, and then you hear electric potential energy. They both have the word potential, right? They both have something to do with energy, and they both are measured in electrical systems. So naturally, many people would assume that they're simply two names for the same thing. In fact, this confusion is very similar to everyday language. For example, people often say speed and velocity are the same, weight and mass are the same. But in physics, those pairs have different meaning, and the same thing happens here. So why does this misconception happens? I think there are three common reasons. Number one is the name are almost identical. And yeah, I agree. Potential sounds like a shortened version of potential energy, and people subconsciously think that potential is equals to potential energy. And I think that's valid. I myself also experienced that. And then number two is that textbooks often introduce them together. A problem set might say a positive charge placed in an electric field against in an electric field gains electric potential energy. The electric potential at this point is blah blah blah. So since both ideas are presented simultaneously, beginners often blend them into one concept. Another would be they both involve the idea of stored energy. And when people think potential, they think of something that is stored and ready to be used. That is not entirely wrong. But the crucial question is stored energy of what, right? The single question separates the two concepts. So, if they aren't exactly the same, then what is the difference? The correct statement would be electric potential is the electric potential energy per unit charge. Now, it would be easier for us if we have a gravitational analogy for electric potential. And for this topic, and for electric potential, it would be the height, right? Uh, if we have an object at some height, that object will spontaneously fall to the lower height when we drop it. and the object on the ground will not go spontaneously upward, right? And the same is true for electric charges. Charges will not move spontaneously. Charges would move spontaneously to a certain direction, and the motion in the opposite direction would be the non spontaneous. However, at which direction it would go would be a little bit more complicated because for gravity, down is always the spontaneous motion, right? While up is the non spontaneous. But for charges, since it can be either positive or negative, we cannot say for sure. So the mathematics will tell us if it goes up or down. But the point is, it is a little bit more complicated than our gravitational analogy. Now, if we put our if we put a change on our electric potential, it would mean that there is also a change in our electric potential energy per unit charge. You see that equation right there, V is equals to U divided by Q. Or if we rearrange that one, that would be U equals to QV. So the electric potential is equal to the electric potential energy U divided by our unit charge. So looking at our gravitational comparison, which we have here, the equation U equals to mgh, uh, the object at some height would have a higher potential energy than it would be when it reaches the bottom, right? So, for example, a ball at, at a tower, for example, it would have a higher potential energy than it would be at the top. It would have a higher potential energy at the top than it would be at the bottom. And I think that is the main picture for this uh, topic, meaning that the charges would move spontaneously in the presence of potential difference. So, uh, if a conducting path is available, like a wire or a conductive fluid like water, uh, negative charges will flow towards more positive potential, whereas positive charges will flow towards more negative potential. Uh, that is just another way of saying opposite charges attract each other. Then we have here our equation, right? We can use some numbers so that we would prove that electric potential and electric potential energy is not the same. So suppose in a location we have a electric potential V of 10 volts. If we place a charge of 1 coulomb, its electric potential energy becomes what? 10 joules, right? Because U is equals to QV. We would have 1 coulomb times 10 volts, 10 joules. Since it is a since it is a unit of energy, we would use joules. But what if we place a 2 coulomb charge? Still, the electric potential is the same, 10 volts, and then we would have 2 coulomb charge. What would now be the electric potential energy? would be 20 joules, right? So notice something important. The electric potential stayed exactly the same as 10 volts, only the amount of charge changed. It was one column at first and then two column when we change it. So this proves that electric potential and electric potential energy cannot be identical. One stays fixed as a property of the location, and the other changes depending on what object you put there. So, our takeaway would be electric potential energy is not equal to electric potential. So, if you remember only one thing from today's presentation, let it be this. Electric potential is not the energy itself, it is the amount of energy available for every unit charge. Meanwhile, electric potential energy is the actual energy the specific charge possesses because of its position. So, I think that would be all. Thank you so much for listening, and I hope the next time you hear the words electric potential and electric potential energy, you won't get confused. So, thank you so much for listening, and God bless you. See you next time. Bye bye.